The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to pick up continuing to review outcome 3 in preparation for the final exam. So let's go ahead and get started. There we go. So this is not going to work yet. Let's try it now. There we go. Number 18. It says solve 2 times the quantity 14d minus 17 equals 8. So the first thing we're going to do is simplify everything on both sides of the equation. On the left side of the equation, inside the grouping symbol, we have 14d minus 17. Those are not like terms, so we can't combine them. So we're forced to distribute the 2. 2 times 14d is 28d. 2 times minus 17 is minus 34. And then on the right, we can't do anything. It's just equals to 8. So now to isolate the variable term, we'll add 34 to both sides of the equation. 28d equals 42. Then we'll divide both sides of the equation by 28. That reduces down, let's see, 42 over 28. Let's see what that is. 42 divided by 28 comes out as 1.5 or 1.5 or 3 halves. We'll go ahead and go with 1.5. Let's see what they did. They did 3 halves, but 1.5 should also work. And there we go. There we go. Okay. Number 19 coming up. Solve 9x minus 5 times the quantity 2x minus 5 equals -5. So again, we're going to simplify each side of the equation. On the left side, we can't do anything with the 2x minus 5. It's not like terms. So we will distribute the -5. -5 times 2x is -10x or minus 10x. Minus 5 or -5 times minus 5 or -5 is plus 25. And again, we can't do anything on the right side yet. Combining like terms, 9x minus 10x is -1x. And then plus 25 equals -5. Isolating the variable term, we subtract 25 from both sides of the equation. We get -x equals -30. Isolating the variable, dividing both sides by the implied -1 coefficient, x equals positive 30. Okay. Again, I'll just keep going, but if there's any questions, please stop me. Number 20, solve 75d plus 6 equals 6 times the quantity 5d minus 5. Write your answer as a reduced fraction or integer. Okay, so here a decimal wouldn't work. All right, let's see. I can't do anything yet on the left side of the equation, but on the right side of the equation, I'm going to distribute the 6. So I get 30d minus 30. I have variable terms on both sides of the equation. I need to get them all on the same side. I'm going to put them all on the left side. So I need to get rid of the 30d on the right, but since I'm subtracting 30d from the right side, I must also subtract it from the left side. 75d minus 30d is 45d plus 6 equals -30. Subtract -6 from both sides, or rather subtract 6 from both sides. 45d equals -36. Divide both sides by 45. Now, My temptation might be, well, let's go to the calculator and see what we get, but I don't want a decimal answer, I want a fraction. 9 goes into both 36 and 45. So if we divide by 9, on top, negative 36 divided by 9 would be negative 4. 45 divided by 9 would be 5. So our answer should be negative 4/5. And again, it said to put in a fraction or an integer. So negative 0.8 would not work, or shouldn't work anyway. Negative 4/5. Okay. Let's go on to problem 21. Solve 4c plus 7 minus the quantity 3c minus 9 equals the quantity 2c plus 3 plus the quantity 3c minus 2. Okay. All right. On the left side of the equation, there's nothing in front of the first set of parentheses, so I can just copy it without the parentheses. It's like distributing of 1, which doesn't change anything. The minus sign in front of the second set of parentheses changes the sign of each number inside. It's like we're distributing a -1. So we get minus 3c, and then minus times minus is plus 9. The next set on the right side, we get 2c plus 3. And then with a plus sign in front of the next group, 3c minus 2. So now we've gotten rid of the grouping symbols. Next, we'll combine like terms. 4c minus 3c is 1c. 7 plus 9 is 16. So c plus 16 equals, on the right side, 2c plus 3c is 5c, and 3 minus 2 is plus 1. I need to put all the c's on one side of the equation. I can put it on either side of the equation. Let's put them on the right this time. So I'll subtract c from both sides to get rid of c on the left, but that gives us 4c plus 1 on the right. Since I opted to put the variable terms on the right, the constant terms go on the left. So subtracting 1, 15 equals 4c. Divide both sides by 4. C equals 15/4. And let's see, it doesn't give any directions as to the answer. So 15/4, let's see what they did. They did that. I'm curious whether I could use a decimal. 15 divided by 4 would be a 3. And then 3.75. Let's see what happens. I'm just curious. I put in 3.75. 3.75. Yeah, it accepts it because it didn't say, I don't know back here if we put in a decimal, if it would have liked it or not, but I'm not going to mess with it. Anyway, you could also put in -4/5, or not -4/5, 15/4, excuse me. All right. 22. Solve 3w minus 1 equals 6 minus the quantity 2w minus 8. I can't do anything to simplify the left side of the equation yet. On the right side, distributing the minus sign, I get minus 2w, and then minus times a minus 8 is plus 8. Continuing on the right side, I can combine the 6 and the 8 to get a plus 14. I'm going to put all the w's on the left side of the equation. So I'm going to add 2w to both sides of the equation. I get 5w minus 1 equals 14. To isolate the variable term, I'll add 1 to both sides of the equation. So 5w equals 15. To isolate the variable, divide both sides by the coefficient of the variable. W equals 3. Continuing on. Number 23, 0.59 times the quantity x minus 490 equals 0.13x. Oops, that wasn't an equal sign. That was a subtraction sign. My bad. Let's go here and fix that. Okay. So minus 0.13x equals 0.83x minus 455.6. Okay. On the left side of the equation, we're going to start out by distributing. So we get 0.59x. Then we're going to take 0.59 times negative 490, which is going to be minus 289.1. And then minus 0.13x. Combining like terms, 0.59x minus 0.13x would be 0.59 minus 0.13 is 0.46x minus 289.1 equals, and on the right side, 0.83x minus 455.6. Okay. Oh, let's put all the x's on the right side. So I'm going to subtract 0.46x. So I get negative 289.1 equals 0. What is that going to be? 37. If we take 0.83 minus 0.46, we get 0.37x, and then minus 455.6. Okay. Since I've got the variable term on the right, I want the constant term on the left, so I'm going to add 455.6 to both sides. So let's see here. What have I got? I've got negative 289.1 plus 455.6. Okay. And I get 166.5. Then we're going to divide both sides by 0.37. And let's see, divided by 0.37, and we get 450. After all that, we got a nice number. Oh, one solution, x is no solution, infinite number of solutions. Well, we've got just the one solution. So one solution, x is 450. 450. Okay. And now we've got some word problems. Everybody's cheering with excitement, I can tell. Okay. So the key to this is to start out with figuring out what they want to know, then calling that our variable, we'll use x, and then going from there. Patricia rode her bike a total of 12 miles from home to the library and then to the beach. The distance from Patricia's house to the library is 5 miles. What is the distance from the library to the beach? All right, so distance from library to beach. That's the question. Let's call it x, okay? Patricia rode her bike a total of 12 miles from home to the library and then to the beach. So from home to the library to the beach is 12 miles. The distance from Patricia's house to the library is 5 miles, And the distance from the library to the beach, we don't know. So the total trip is 12 miles. The first part of the trip is 5 miles. The second part of the trip is the unknown. So we get this equation. Any questions about how I got the equation? All right, to solve the equation, we'll subtract 5 from both sides. So x equals 7. So distance from library to beach would be 7 miles. They already have units of miles written, so I would just put a 7 in there. And there we go. Again, any questions before we go on? Okay. Number 25. Melanie's daughter is 3 years younger than her son. Melanie's son is 17 years old. How old is her daughter? So the question is, how old is her daughter? And let's call it X. Melanie's daughter is 3 years younger than her son. Melanie's son is 17 years old. So Melanie's son is 17, but the daughter is 3 years younger than her son. If the daughter is 3 years younger than the son would be 3 years older than the daughter. So this is the son, and that's the son. I don't know if that makes sense, because we're asking, the question asks about the daughter, but the son is 17 years old, the daughter is X, but the daughter's 3 years younger. So to make her equal, you'd have to add 3 years to it. I'm getting a blank stare there. Okay.
Shouldn't that be a minus? Should be 17 minus 3.
Well, you're right, but watch what's going to happen next. There's your 17 minus 3. So maybe the way you saw it, Whitney, is to write it like this in the first place.
Yeah.
And that's okay. Yeah, that accomplishes the same thing. In either case, X is what? 14. So 14 years old. I know this one's a little bit tricky the way it's worded. Let's see what they did. Yeah, they did it this way, but again, the way that you approached it is also correct. Okay, now 14, and I guess they don't want units on it, but whatever. Okay. Going on. 26. For a family birthday dinner, Gage bought a turkey that weighed 2 pounds less than the one she bought for Thanksgiving. The birthday turkey weighed 12 pounds. How much did the Thanksgiving turkey weigh? Okay, so weight of Thanksgiving turkey, and we're going to call it X. Let's see. Gage bought a turkey that weighed 2 pounds less than the one she bought for Thanksgiving. The birthday turkey weighed 12 pounds. So the 12 pounds is 2 pounds less than the Thanksgiving turkey. See if we can figure that out. Okay, so the birthday turkey was 12 pounds. Okay, so that's here, 12 pounds. The Thanksgiving turkey, let's see here. The birthday turkey is 2 pounds less than the Thanksgiving turkey. So here's the birthday turkey. Here's 2 pounds less than the Thanksgiving turkey. You following that okay? All right, so we'll add 2 to both sides. Thanksgiving turkey, 14 pounds. Zair's paycheck this week was $12.72 less than his paycheck last week. His paycheck this week was $112.42. How much was Zair's paycheck last week? Okay, so how much check last week? Call it X. His paycheck, let's see, was $12.72 less than his paycheck last week. Okay, so this week is $112.42, which was $12.72 less than his paycheck last week. And again, you might say, well, can I just set it up 112.42 plus 12.72 equals X? And if you read it that way, that's fine. Okay, there's nothing wrong with that. Let's see, what do we get now? Because again, that's what we ultimately end up with. And got all our dollar signs. Let's see, that's what, 4, 11, 5, 2, 1. So $125.14. Okay, that's right. They've got the dollar sign over there. Okay. 125.14. Okay. Let's take a look at number 28. Carolina paid $6.56 for a pack of 4 pairs of socks. What was the price of 1 pair of socks? Okay, so price of 1 pair of socks. Call it X. So $6.56 is the price of 4 times the price of 1. Now, I understand perfectly if you look at this and you read it and you go, oh, all you have to do is take $6.56 and divide it by 4 and you get the answer, and that's true. So then you're thinking, why go through all of this stuff? What we're doing is we're getting you used to creating equations that are, I'm going to say, relatively simple. Now, not necessarily simple, but relatively simple to what things will be when they get more complicated. So practicing when they're the more basic ones will help you with the more complicated ones. That's why, even though you might say, well, just take 656 divided by 4, which is exactly what we're going to do now, setting it up is an important part of the process. Okay. So $6.56 divided by 4 is $1.64. All righty, number 29. Kevin's SUV gets 19 miles per gallon, MPG. This is half as many MPG as his spouse's hybrid car. How many miles per gallon does the hybrid car get? So, how many miles per gallon does the hybrid get? Question mark. Kevin's gets 19 miles per gallon. This is, oh, excuse me, call it X. So the MPG for the hybrid is X. Kevin gets 19, and this is half as many as his wife's spouse's hybrid gets. So 19 is half of the other. To find the other, multiply both sides by 2. 38 equals X. So 38 miles per gallon should be the answer. All right with that? Okay, apparently so. You're all just picking this up fairly well, or you're just stunned and don't know what to say. Okay. Number 30. Suppose 3/4 of the students in a biology class are female. If there are 24 females, what is the total number of students in the class? Total number of students, call it X. So 3/4 of the students in a class are female. So are 24. So students in the class is X. So you've got 3/4 of X represent the females and 24 represents the females. Okay. Oh, but here we've got a coefficient that's a fraction. So we're going to multiply both sides by the reciprocal of that fraction. The 4's reduced down to 1/1, the 3's reduced down to 1/1, so you get 1 times X or just X. On the right side of the equation, 24/3 is 8/1. 8 times 4 is 32, so the total number of students would be 32. Okay. 31. I don't know, is that Layla? Maybe. Layla or Leia? I don't know, Layla is organizing paperback and hardback books for her club's used books sale. The number of paperbacks is 12 less than 5 times the number of hardbacks. Layla has 148 paperbacks. How many hardback books are there? How many hardback books? Call it X. The number of paperbacks is 12 less than 5 times the number of hardbacks. So the paperbacks is 12 less than 5 times the number of hardbacks. We also know that there are 148 paperbacks. So what we've got going on here, same as the last problem, we've got the number of paperbacks described 2 different ways. It's given outright as 148. It's also given as 12 less than 5 times the number of hardbacks. So here's 12 less than 5 times the number of hardbacks equals 148. Add 12 to both sides. 5x equals 160. Divide by 5, x equals, let's see, that's going to be what, 32? So how many hardback books are there? 32. Okay. Continuing on, number 32. Corey pays $1,790 in rent every month. This amount is 130 more than twice what his brother Lewis pays for rent. How much does Lewis pay? Okay, how much does Lewis pay? Call it X. Corey pays 1790. So there's Corey. This amount, Corey's amount, is $130 more than twice what his brother pays. So here again, we've got a situation where even though they're asking about Lewis, they're describing Corey's pay in 2 different ways. They're telling us it's $1790 and it's $130 more than twice Lewis. Lewis is X, twice X plus 130. Okay. Subtract 130 from both sides. And we get what, 0.661. Divide both sides by 2. And we get 830. So that would be $830. I'm concerned because there should be a dollar sign there in front of it. Let's see what happens if I put it in there, if it accepts it. Okay. Units matter. All right. Let's see here. Number 33. In a cash drawer, there is $220 in $10 bills and $5 bills. The number of $5 bills is twice as the number of $10 bills. How many of each are in the drawer? Okay. How many of each are in drawer? And we've got two different things. We've got $5 bills and $10 bills. Okay, there's two things they want us to find out. What do we know? The number of $5 bills is twice as much as the number of $10 bills. So that's a comparison statement. The number of fives is being compared to the number of tens. So let's say we call the number of $10 bills X. There's twice as many $5 bills, so that would be 2X. In a cash drawer, there are $220 in $10 and $5 bills. So the 2X plus the X equals $220. Okay. I'm a little concerned here because, let's see, hang on. This isn't going to work out right because there's something important that I've missed. And that is this. We've got 2X times the number of $5 bills and X times the number of $10 bills, right? This gives us the value of them. This gives us the number of them. So those aren't a balanced situation, but let's consider this. If there's X $10 bills, how much would X $10 bills be worth? So let's go total value. That would be 10X. $10 times the number of bills. What's the total value of the $5 bills? Well, that's 5 times the 2X, which is also 10X. Well, 10X plus 10X equals 220. 20X equals 220. Divide both sides by 20. And let's see, if we take 220 divided by 20, we get 11. So there are 11 of those and 22 of those. First of all, let's see here. So there's 11 $10 bills and 22 $5 bills. Okay, let's go back for a minute, look at this, because I didn't do it really straightforward. It took me a minute to figure out what to do here. So are you understanding why I went with a total value? In other words, this initial thing that I wrote, 2X plus X, that's the number of bills, but $220, that's the value. And so those aren't equal things. I had to have the value equals the value.
Isn't this one of the ones we set like the table up for?
Yeah, probably. And that's kind of what I sort of made a makeshift table at the end. Do you want me to make a table for this, or are you okay?
No, I'm good. I'm just making sure I was on the right kind.
Yep. Yeah. What happened is they shifted problems on me and I didn't catch it until I started looking at the equation. It's like, oh, that's not going to work. Okay. So now let's see what they do. Yes, we're back to the tables. And let's see here, dimes, nickels, and quarters. So dimes, nickels, quarters. And then we're going to have number of each. And then we're going to have total value in, and it's going to be in cents. Okay. All right. Carolina has $7 in dimes, nickels, and quarters. If she has 5 times as many nickels as quarters, in that situation, the quarters is the center of the universe. The nickels are being compared to the quarters. And then it goes on and says, and 8 less dimes than the number of quarters. Again, the quarters are what's being compared to. So we've got 2 different comparison statements, but they're both being compared to quarters. So quarters is going to be our X. Now let's go back. 5 times as many nickels as quarters, so 5X. 8 less dimes than quarters, X minus 8. Any question about where I got the number of each? All right. A dime is worth 10 cents, and I'm going to do this in cents, okay? In cents. So X minus 8 dimes would be worth 10 cents times X minus 8. 10 cents a piece times the number of dimes. A nickel is worth 5 cents, so the total value of the nickels would be 5 cents times the number of nickels. A quarter is worth 25 cents, so the total value in cents would be 25 cents times the number of quarters. If I take the total value of the dimes plus the total value of the nickels plus the total value of the quarters, all in cents, I get the total value, which is $7 or 700 cents. Are you okay with that? The alternative approach is you would use 0.10 X minus 8, 0.05 5X, 0.25 X, and you would have it all equal to 7.00. That would be doing it in dollars because these are units of dollars. Okay. All right. So what do I got? I've got 10X minus 80 plus 25X plus 25X equals 700. 25 plus 25 is 50 plus 10 is 60X minus 80 equals 700. Add 80 to both sides. 60X equals 780. Divide both sides by 60. X equals, what is that? 13, I think. Let's see. 780 divided by 60 is 13. So this is 13. This is 5 times 13, which is 65. This is 13 minus 8, which is 5. So how many quarters? 13. How many nickels? 65. How many dimes? 5. Any questions about how I did that? All righty. See, how many questions have we got? We still got a ways to go. Well, if we don't get through them today, we'll pick it up on Monday, Tuesday rather. No school on Monday. Okay. 35. A local theater sold 500 seats for an upcoming play. Ticket prices for adults are $55 and ticket prices for children are $23. If the theater made $21,548 for the show, how many adult and children attend? Okay. So how many adult shouldn't it be how many adults? Oh, well, how many adults and children attend? Okay. And let's see here. We've got, oops, adult, what, tickets, or just adults, children, because each person represents one ticket, right? Okay. Let's see, a local theater sold 500 seats. Number of each. Let's say this represents 500 seats, okay? So this whole thing is 500, right? Let's call the number of adult tickets X. So if I had 500 tickets and part of it was the adults, this part of it is X, what do I have left? Well, isn't this 500 take away X? You see what I did there?
Yes.
Okay. The rest of you on board with that? It gets a little tricky at first. So here's 500. This is X. This is 500 minus X. All right. Then we want the value. So total value. And this is going to be in dollars because everything is given in dollars. In dollars. An adult ticket is $55. So we got $55 times X. Children's tickets are $23. So $23 times 500 minus X. So the value of the adult tickets plus the value of the child tickets equals the total value, which was $21,548. Okay. We all right with this? So this is very much like the problem we just did with the coins, but the relationships are described as a total of 500, part of it's X, part of it's 500 minus X, instead of what it was in the previous one. So what do we get here? We get 55X plus 23 times 500, which is 11,500 minus 23X equals 21,548. Combining like terms, 55 minus 23, 32X plus 11,500 equals 21,548. Subtract 11,500, 21,548 minus 11,500. And we get 32X equals 10,048. Divide by 32. We get 314. So, whoops, there's 314 adult tickets, and then there's 500 minus 314, which is 186 children's tickets. Children's tickets, 186. Adults tickets, 314. All righty. Okay, let's go on to the next problem. And they already have a table set up, so that's kind of nice. And let's see here. Let's see, I need 4 rows and 4 columns. Work area, this is 340 per pound, 780 per pound, 598 per pound, number of pounds, cost per pound, value in dollars. Okay. A store has two types of nuts that they will mix together to make a mixture worth $5.98 a pound. If the store uses 12 pounds of a nut that costs $3.40 per pound, so this is 12 pounds. Okay, they use 12 pounds, it says right there, of a nut that's $3.40 per pound. How many pounds of the nuts that cost $7.80? So this is our unknown. That should make a mixture. All right, now, suppose this is the $3.40 per pound nuts. So this is 12 pounds, okay? This is the $7.80 per pound nuts. This is X pounds. What's 12 pounds? Don't overthink this. What's 12 pounds plus X pounds?
$5.98 a pound.
But that's not the number of pounds. 12 pounds plus X pounds is how many pounds?
12x.
No, that would mean multiplication. Tell you
12
what,
plus X.
yeah, and I know it's tricky. Brandon, 12x, that's the typical answer I get because it's like, well, let's put them together, but you're just adding them. That's why I say don't overthink it. 12 plus X is 12 plus X. You okay with that? Brandon, you okay with that? He's gone.
Yes.
Okay, sorry. All right. So we've got 12 pounds at $3.40 per pound. So what's the value of that? If we take $3.40 per pound times 12 pounds, here's where we're going to multiply. The total value is $40.80. And then let's see here. We've got, this is $7.80 per pound. We've got X pounds at $7.80 per pound. So that's going to be $7.80 times X. That's all we can do with it at this point. Then we've got $5.98 per pound times X plus 12. So this is going to be $5.98 times the quantity X plus 12. All right. So now we've got to be careful. How are we going to set up our equation? We're going to take these plus these and mix them together to get those. So $40.80 plus $7.80 times X equals $5.98 times X plus 12. Okay. And I've got my circle going right through the middle there. Let's see if I can erase that, get it out of the way. All right. So the total value of the first mix plus the total value of the second, or the total value of the first bunch of nuts, total value of second bunch of nuts equals total value of the mixture. All right. Let's see, we're going to distribute on the right side. So we get 5.98x plus, let's see here, 5.98 times 12 is 71.76. I'm going to put all the x's on the left, so I'm going to subtract 598x from both sides. So I get 40.80. And over here I get 71.76. And let's see, 780 minus 5.98 is 1.82x. Okay. Subtract 40.80 from both sides. 1.82x equals 71.76 minus 40.80. 30.96 divide by 1.82. Oh, I panicked. I got 17.01098, but it says round to the nearest whole pound. Nice. So I got 17.01098,901. So it'd be 17. Okay. So this is 17. This is 17 plus 12, which is 29. Now, it says the store should add how many pounds of nuts worth 780? So that's the 17. All righty. Okay, we're out of time. Let's see, what do we got? 37, 38, 39. We got a bunch more. I will pick these up on Tuesday, and we'll do our best to get through everything we've got 4 days next week. Okay, so again, we'll pick it up on 37 on Tuesday. Have a great, safe Memorial Day weekend. I'm going to stop the recording.